Stay hungry, stay foolish.
Albert Einstein once said, if I had 20 days to solve a problem, I'd spend 19 days to define it. The world of innovation is confusing because everyone has a different concept of what innovation is, and everyone is solving a different problem. What if the key was to match the right solution with the right problem? Find problems for your solutions you already have. Now let's use that concept for this show. Defining the problem for today's show, our question is, how do some companies innovate consistently and others are just one-hit wonders or just peter out and die? Today's guest has written a fantastic book which looks at existing frameworks and gives us a formula to map the right solution to the right problem. We welcome speaker and innovation advisor, best-selling author of Mapping Innovation, Greg Satell. Welcome to the show, Greg.
Thanks for having me, Aidan.
It's great to have you on the show. I absolutely devoured this book twice, and I'm fearful that we won't get through today's show in one show, the amount that's in this. There was so much in it, and I highly recommend anybody that's interested in the space to buy it. What I love about it is how you develop the book. You frame the problem well with clear examples and then connect all the dots so well throughout the book. So let's get into it because we have so much to go through. You tell us at the very start, Moore's Law has been a map for innovators, so they have a rough map of the future. But now Moore's Law is coming to an end, and we have to create a new map. I thought a great way to start, Greg, would be what you talk about with Douglas Engelbart and the mother of all demos.
Douglas Engelbart had a very particular problem he wanted to solve. He had read a famous essay by a guy named Vannevar Bush, who was really the architect of the scientific and innovation architecture that we built in the United States during World War II and after World War II. And Bush had written this essay in the Atlantic magazine about how he saw computers evolving into a device I think he called like a Memex, which was really pretty much what he was describing was the internet. But what you have to understand was back in the 1950s and 60s, computers weren't anything that a normal person would use. It was more like a spaceship today. I mean, we know they exist, but we don't use them. Very few people have personal interactions with them. And Engelbart had this idea of a computer being something a new class of professionals he called intellectual workers would use. And he built up this demo, which was so important that now it's called the mother of all demos. He was funded by DARPA, the Defense Advanced Research Projects Agency, the same one that developed the internet. And he had this demo where he would interact with the computer using just a keyboard and this device he called a mouse. And he was able to do a lot of the things that we take for granted today. Things like be able to create and edit a document on the fly. He was able to input sound in video, manipulate things on the screen. And this was back during the time when you interacted with a computer, you would get a printout maybe an hour later on a shared system. The idea of a personal computer was considered pretty outlandish. But then just a few years later, some of his disciples built a prototype at Xerox PARC. They refined it over the next decade. Steve Jobs got wind of it. That became the Macintosh. And of course, we entered the personal computing age. But what I think that people don't get about innovation is that took about 30 years to go from the mother of all demos in 1968 to the productivity boost we finally got from computers and the internet in the late 90s. And in the interim, there were all these different problems to solve. And it wasn't just one person like Douglas Engelbart or Steve Jobs. It was literally thousands of people all solving those intermediate problems that created what we know as the PC revolution. So I think where a lot of people get stuck is they think that innovation belongs only to some genius like Jobs or Bezos or Elon Musk. But innovation is something that's really a team sport. That, I think, is the part that most organizations get wrong.
The reason I started with this was because Engelbert would be somebody who was reasonably unknown to most of us, versus I hope we're going to talk a little bit about Darwin and Einstein, and they're seen as the genius, the standalone genius, but they all, as you say, stand on the shoulders of giants, and it's a collaborative sport. It's not one person coming up with the idea. And I thought this was brilliant the way you said this about Engelbert, because Jobs, for example, on the iPhone was not just Jobs on the iPhone. They didn't even use original chips, for example, for the iPod. And I'd love to share a story like that.
Well, the iPod's a great one. And I think goes to the point about the end of Moore's Law and the new era of innovation. Jobs had this idea for 1,000 songs in your pocket. And that was basically the idea for the iPhone. It also represented a pretty clear technical specification. Once you say, I need 1,000 songs in my pocket, you can work back from that to exactly the size and capacity of a hard drive you need to make such a device. The problem was when Jobs had that idea, it was technically impossible. You couldn't get a hard drive that small with that kind of capacity. But within a few years, a supplier, I think it was Toshiba, came up with one. Jobs sent somebody out there to buy basically the whole production run, and they made the iPod. And that was really the first big step in the resurgence of Apple. But what's interesting about that story is notice how pretty much all of the value went to Apple. The supplier got obviously a very good sale, but it wasn't really transformative for the hard drive manufacturer. It was transformative for Apple that engineered a device and designed the user interface. And that's really where we are with technology today. And that's what most people consider innovation to be, that type of rapid iteration, design thinking, and that connection to the consumer, to the end user. And that's certainly important. That's obviously very, very important. People need to use technology. But that's not the whole thing. Those things have only become important because we've come to understand the underlying technology really, really, really well. I mean, we've been making computer chips for a very, very long time. And when a new generation of computing chips comes off the line, it's better, it's faster, and it's cheaper, but it works the exact same way as the chips that came before it. So we've pretty much had that fundamental piece really just for free. Every 2 years, our technology becomes more powerful and cheaper, and everything becomes easier. But we're coming into a new phase where chips don't get any faster. We have maybe 1 or 2 more generations of chips, maybe 2 years, maybe 4 years, possibly 5 years, but not beyond that. And we're going to have to figure out what we're going to do. What do you do when the underlying technology doesn't get any better? The obvious answer is that you jump to a new technology, and there's new computing architectures that are very, very exciting. Quantum computing is something that in the last year or so people have been talking a lot about, which is really exciting. There's another technology called neuromorphic computing, which is also very exciting, but it's gone quiet for a year or two. To be honest, I don't know what's going on there. But what you need to understand about things like quantum computing and neuromorphic chips, they don't work anything like a computer as we know it. A quantum computer doesn't solve the same types of problems that a classical computer does. So we're going to have to figure out how we're going to use those technologies, and that's going to take a while. So we've spent the last couple of decades learning how to move faster. We're going to have to spend the next few decades relearning how to go slow again.
I love that, man, because you make this key point that computers just didn't just work. They needed people to adopt them and see the need. They needed people to find the problem for the solution that was discovered. And you say this, Jobs, just like Engelbert, was an accomplishment of vision over engineering. But that brings us nicely to your point there of, say, somebody like Fleming. So Alexander Fleming and penicillin, for example, they discover something, they discover a solution, but it almost is like it goes into the time warp incubator and it waits for a time when the world is ready for it, or the world is ready for that solution to a problem it doesn't know yet.
Well, in that situation, it was actually worse. A lot of people have heard the story of how Alexander Fleming sort of went into his lab after his summer vacation and realized that this mold had infected his petri dishes, and how he immediately pivoted to from growing bacteria to studying the mold, and that's how he discovered penicillin. But the part that people leave out of this story is that when he published his findings, nobody really noticed and nobody really cared, because what Alexander Fleming discovered was absolutely useless. What he discovered was simply a secretion from a mold that could kill bacteria in a petri dish. You couldn't store it, the compound wasn't stable. You couldn't inject it. You certainly wouldn't want to ingest it. I mean, can you imagine that, going to the doctor's office and him telling you, "Oh, I've been growing some mold in the back." Uh,
Give me a slice of that bad boy.
and you couldn't make nearly enough of it to be therapeutically effective. And it took 10 years for a completely different team to rediscover his findings. And while Fleming was pretty much a sole researcher, this team had a much bigger team with a much more diverse set of skills. So Howard Florey, who led the team, he was a pathologist, very much like Fleming was. But Chain was a biochemist, exactly the type of guy you would need to transform this mold juice into a storable powder. And they had another guy on the team that devised this fermentation system so they could make more of it. And they also had technicians so they could do mouse studies. And that's how they realized that this could be really effective. But even then, the first patient they tried to cure, he ended up dying because they ran out of penicillin and they couldn't make it fast enough. So they had to work with other labs. They went to the States. They found a new strain of the penicillin mold that was far more potent. They found a much more effective fermentation medium. They started working with pharmaceutical companies to develop mass manufacturing methods. Logistics needed to be worked out. So what we hear about is this one lone genius in the single moment of epiphany actually turns out to, have accomplished several different labs, hundreds, if not thousands of people when you factor in all the problems with production and logistics and manufacturing and everything else that you need to fix to actually make an impact. And even then, when they first deployed penicillin in World War II, a lot of doctors didn't want to use it because they'd been treating infections for years. Not particularly effectively, but they'd seen some people get better. They didn't know anything about this newfangled penicillin, and they weren't crazy about risking their patients' lives on something they didn't really understand.
That paradigm problem, let's look at that for a second, because you tell us the tragic, really, case of Semmelweis and the hand washing problem.
Yeah, I recently wrote an article about Semmelweis because I think people get the wrong idea about Semmelweis. Semmelweis, just to remind your listeners, he was the guy who came up with this idea of hand washing in hospitals. And he was able to show that he could greatly reduce mortality rates, but the medical establishment wouldn't accept it. This is somewhere in the late 1840s. And the germ theory of disease didn't become widely accepted until the 1860s. So millions of people died because this didn't get accepted. But what people miss about that story is a lot of the blame falls on Semmelweis himself, because he absolutely refused to format his data and to validate his findings in a way that would make his idea more acceptable. And people talk about, how do you overcome? I get asked this a lot at conferences I speak at. People say, how do you overcome that Semmelweis problem where you come up with this breakthrough idea and nobody will accept it? How do you get people to accept your ideas and listen to your ideas? Well, nobody's going to accept your idea. That's not how it happens. You have to make your case. There's another guy I interviewed for the book. His name was Jim Allison, and he came up with this idea of fiddling with your immune system so that your immune system can attack cancer. He figured out that if you could inhibit this particular molecule, that it would sort of unleash your immune system to fight cancer. And he went to all the pharmaceutical companies, and they all told him, no way. They said, no way we're going to invest in that. And it wasn't because they didn't understand it, but because they had blown billions of dollars across hundreds of different trials with immune approaches to cancer back in the 1980s. And nobody wanted to get burned on the same thing. They'd sort of learned their lesson. So Jim could have easily said, oh, wow, there's the Semmelweis problem. I'm just like Semmelweis. I'm this sort of lone genius who nobody will accept. But he didn't do that. He went back to his lab. He validated his findings further. He pounded the pavement. And eventually he found a small biotech company that was willing to invest. And in 2010 or so, that small biotech company was acquired by Bristol Myers Squibb for, I think it was $2.8 billion. And of course, today, cancer immunotherapy is not considered anything speculative, but it's become the fourth pillar of cancer treatment. Many people consider it to be a miracle cure. And Jim is probably on the shortest of short lists for Nobel Prize. That's how you solve the Semmelweis problem. You keep at it, and you make your case.
Let's keep going, because I thought, and this is a really important one. I love this, Greg, because I use this one from my son, who's 8 and is big into science and a big Einstein fan and Darwin, and you write about both of them. And I love this because I never had looked at it this way. Einstein, for example, was really a late bloomer. It wasn't just one moment of clarity that he came up with the theory of relativity. It was a mixture of imagination and curiosity and a little bit of serendipity as well.
Well, it took him 10 years, right? It was a problem he'd been thinking about since he was a kid. There was a boarder at his house that was a science student and explained to sort of young Albert about the speed of light and how there was a limit on how fast the speed of light could go. And he started thinking about it, and he realized that the way he chose to thought about it, okay, so what happens if I'm riding on a bolt of lightning and shining a flashlight forward? How fast would the flashlight be going? Because if I'm already going at the speed of light, and that's the limit that the speed of light can go, then how can the light beam I'm shining from my flashlight, how can that be going faster than the light bolt I'm riding on? So either the speed of light is relative or time and space are relative. And it took him, he spent 10 years figuring that out. And then it took him another 10 years to figure out general relativity. So people who solve important problems, it takes them a while. You hear about maybe this flash of inspiration, but that flash of inspiration comes after studying the problem for quite some time. And that brings us to another issue I hear a lot about, of whether you want experts working on the problem or outsiders working on the problem. Because often the flash of insight comes from some outside influence. You brought up Darwin. What sort of set him on the road to natural selection didn't have anything to do with biology or zoology or geology or any ologies, actually. He read a 40-year-old economics essay by Thomas Malthus. And that's what sort of spurred him forward. So there's this constant debate about whether you want experts working on the problem or you want outsiders. And the answer is you really need both. You need someone with expertise to understand the problem, to be able to frame the problem, recognize the problem's important, and also be able to recognize what would be a novel and important solution. But there's always some missing bit of information or insight that you need to solve the problem. And that's why you always have to start looking outside. There was a recent study done of something like 18 million scientific papers. And what they found was that the most highly cited papers weren't by specialists or outsiders, but a team of specialists in a certain field working with uh, another specialist from with expertise in some random field that you would never think of. And it's that sort of combination of inside specialist knowledge and that random insight from somewhere else is how breakthroughs happen.
I love the one you talk about where there was a team trying to come up with a way to identify pollution.
To develop a sensor, which is a very, very hard problem. So this company put together a crack team of chip designers and they start discussing the problem. About 45 minutes into it, the marine biologist who's assigned to their team, he walks in and drops a bag of clams on the table. And they all sort of look up at him and he says, "Oh, well, you see, these clams, they can detect pollutants at extremely low concentrations, just a few parts per million. And when they do that, they open their shells. So we don't need any really sophisticated chip to detect pollutants. All we need is a very cheap and simple chip that can detect when clams open their shells." And they basically saved $1 million and they apparently ate the clams for dinner.
I
But
love that.
what I think is really interesting about that is, I mean, obviously that's not, the fact that clams can detect pollution is not common knowledge among chip designers, but it's something almost any marine biologist would know. So that's a great example of how inside and outside expertise can be helpful. But it also highlights how important it is to understand the type of problem you're trying to solve. Because if the problem they were trying to solve was, let's say, how do we make a chip that's 20% more efficient? A marine biologist dumping clams on the table wouldn't be very helpful. As a matter of fact, it'd be pretty disruptive. But with that particular problem, they needed to reach outside. So that's a very, very different approach than something like increasing efficiency by 20%.
I suppose the key message you get across here is that you need to collaborate. You need to look. You need to cast your net wide. Excuse the pun with the clams, but you need to cast your mental net wide to alternative and adjacent disciplines as well as your own, because you won't often find the solution in your own because you're bound by existing paradigms.
Well, not always. Most of the value we get out of innovation is sustaining innovation, which a lot of people consider a dirty word. They call it incremental innovation. But Moore's law is incremental innovation. It's driven a lot of value over the last 30 years. So, like I said, if you're just trying to make a better chip, you don't want marine biologists dumping clams on the table. It's not going to be helpful. And that's how we generally need to do innovation. Most of the time, we need these very clear processes when we understand the problem well and understand the skills that we need to solve it. What's crucially important is that you also understand and are able to recognize when that standard innovation practice doesn't apply, you have to do something else. You either have to iterate solution domains, iterate problem domains, or explore. And I think that's where a lot of organizations get stuck. They pick one innovation strategy. They say, this is how we innovate. This is how this is our innovation DNA. And when they come up with a problem that doesn't fit, they just spin their wheels rather than pivoting to another strategy.
Nice one. And you've teed this up nicely, because this brings us nicely to part two, which is mapping the innovation space, because that is one of the things you talk about, is that you don't just pick one, you have to pick a portfolio of them. And I'd love to explain to our audience, and you do this brilliantly, and it's illustrated as well with great diagrams, the entire innovation space. So you talk about kind of four main places: basic research, breakthrough innovation, sustaining innovation, and disruptive innovation. It'd be great to touch on each of those, Greg.
Well, so the most common is sustaining innovation, and that's when we understand the problem and understand the skills we need to solve it. And that's the sort of typical case. And that's the first thing you want to do. You want to have good, strong people with strong expertise, and you want to define problems well. But sometimes you're working on it for a while and you say, wow, we really understand this problem well. We've defined it really well. We understand the technical specification we're shooting for, but we can't figure out how to solve it. And when that happens, you do need to start iterating the solution space, usually through some type of open innovation. Uh, and that's when things like InnoCentive or Connect and Develop at Procter and Gamble can be very, very good strategies. On the other hand, sometimes, as you've mentioned, you have the solution, but you have to go out and figure out what the problem is. And we can think of examples like Uber or Airbnb, where they took fairly basic technology, solutions that everybody has, and they go out and apply it. They went out and they found a new problem that it can solve. One of the companies I write about in the book is Experian, and they've done very well with their data labs unit. And I was talking to Eric Haller, who's the global director of data labs at Experian, and I said, Eric, you don't really find solutions for problems. What you really do is you go out and you find problems for solutions you already have. These world class data scientists. And he thought about it for a second. Yeah, I never thought about that, but that's really what we do. So understanding what that process is and what your role is really, really super important. And the final quadrant is basic research, that basic exploration. And this is the most neglected quadrant, because people think, okay, well, that's exploration. We don't know where it's going. We don't know what the payoff is. We don't have a clearly defined problem. We don't have clearly defined domains. We don't know the exact skills we need to solve the problem. That's not really for us. But every single organization I looked at that invested in exploration found that it paid off. So the payoff was so big that it far outstripped any of the blind alleys or wrong turns they hit along the way. And really, over the long term, the only way that you can survive in any sort of disruptive environment is to explore. Two of the examples I really like to give. One is IBM, which everybody says is a dinosaur and is going to go bankrupt any day now, and they've been saying it for 70 years, and most people who ever said that have long gone out of business. And and the reason that happens is because they've been around so long. Every 20 years or so, their business seems to absolutely collapse, and people say, "Oh, IBM is finished," and they say, "Well," and they go to their research division and they say, oh, okay, well, here's a brand new technology that nobody's ever seen before. So when digital computers came online, they made tabulating machines obsolete. Obviously, that wasn't a great thing for IBM because they were the market leader in tabulating machines. It absolutely killed their business. But they became a leader in digital computers and then PCs. And now with the cloud, their business of installed solutions is absolutely collapsing and really has collapsed. But they're doing things like Watson and now Debater. They're on the cutting edge of quantum computing, neuromorphic computing, and a bunch of these things that they've been working on for 20 or 30 years. And at any given time, they would have been forgiven to say, this doesn't have any clear payoff. We're not going to make any money in quantum computing, which they started back in the early 90s. So for ever since the early 90s, they've been investing money, not a lot, but money every year on things that they could have been using for more immediate purposes. And now that quantum computing is actually coming to market in the next 5 years or so, they have a future in it. If they hadn't been doing that, IBM certainly wouldn't survive. Now you compare that to GE, which is just a marvelously managed company. Really, really great strategy, famous for how they train their executives. But now they've hit a wall. They made a wrong turn. They made a bad decision. They decided to invest heavily in their gas generation business, just as renewables started to make gas generators obsolete. The difference between GE and IBM is GE hasn't really invested in explorations and hasn't invented anything since they invented CT scanners back in the 1970s. So now it doesn't matter how well the company's managed because they have nothing to jump to. They, for the last 20 or 30 years, they said, okay, we're going to keep our eyes on the ball. We want to have absolute well-defined strategy, understand exactly the problems we're going after, and drive revenues and drive operations and be efficient and do all those things which are important. But they forgot you have to explore because that's what's going to be your insurance policy and that's what's going to be your escape hatch.
I love that. And I love the line you talked about Eric Haller and Experian when he came back to the company and launched the Data Labs project. And he said that the company became trapped in its P&L. And this is one of the problems we see in a lot of companies. And they can't calculate an internal rate of return for exploration or for even innovation of any kind.
Yeah, when something's really new and different, there's no benchmarks, almost by definition, because it's new and different. Those old benchmarks are sort of obsolete. The trick is how you make that exploration sustainable. And the way you do that is you don't spend a lot of money, but you keep at it. And you make sure that you have one of the things I talk about in the book is the 70-20-10 rule, where 70% goes towards innovations that are more sustaining, that they're targeted towards current markets and current capabilities, 20% on adjacencies, and then 10% of your innovation resources towards this exploration. So you're not talking about a lot of money, but it's consistent.
And that leads nicely, Greg, to Google, because Google are an exemplar of using the 70-20-10 rule.
Even with them, and I should stress this, it's not like a physical law. It's a basic rule of thumb. They don't go through and calculate and try and optimize for 70-20-10.
So some companies would CFO out measuring everything.
Oh yeah. Yeah. One thing I'm looking at now is Amazon. And one of the things that Amazon does differently is these 6-page memos. And I can just imagine there's thousands of managers out there now pushing their people to not use PowerPoint and write 6-page memos. What makes the 6-page memos work isn't the fact that they're 6-page memos, but the writing culture that Amazon has cultivated over the last 20 years or so. Another story I talk about in the book that I like quite a bit is about cargo cults. This strange phenomena that happens in some remote islands in the South Pacific, that during World War II, the U.S. military and the Japanese military as well set up bases on these remote South Pacific Islands. So the indigenous people who lived there, they were pre-technological societies. They didn't know what they were looking at. They just saw these men come and do these strange things. They would clear off these long swaths of land, and then they would perform these elaborate rituals. They would march in formation. They would wave sticks in the air, and then these airplanes would come with valuable cargo. Then the war ended, and the soldiers left, and no more cargo came. So they figured we could do that, and they copied the very same rituals. They marched in formation, they waved sticks around. But of course, no airplanes ever came. And anybody who thinks you can wave some sticks around and make airplanes appear is missing some very basic concepts of aviation, right? But you see companies do that all the time. They read about something and they think that by copying rituals, that they'll get the same results. But unless you actually understand the fundamental principles of why something works and how it fits into your particular strategy, capability set, and culture, it's not going to go very well for you.
And Greg, it'd be great to talk about a couple examples now. You've written about these outside the book as well. So if you go to many innovation conferences, and I'm guilty, by the way, man, hand up in the air here, I spoke about this as well. Blockbuster versus Netflix, Airbnb versus the big hotel groups, and Kodak, for example. But you dispel the myths that many, many people talk about there, where they miss the key points of the disruption for those companies.
Yeah, this touches on a bit of what my next book is about. One of the things I talk about in this book is about innovation as a process of discovery, engineering, and transformation. And that transformation phase is the longest and in many ways the hardest. Where Blockbuster failed wasn't that they didn't recognize the threat of Netflix. They actually came up with a very, very clear strategy, an effective strategy to compete with Netflix. It was called Total Access. The problem was that they weren't able to bring along important stakeholders. The investors, they didn't like the strategy because it cost $400 million in depressed earnings. And the franchisees, they didn't like the strategy because they thought it would kill the business they had spent their lives building. And eventually the CEO got fired because of a salary dispute. And the new CEO came in and reversed all the changes. And then Blockbuster failed 3 years later. So it wasn't that they didn't recognize that there was something going on, but they weren't able to make that idea spread throughout their organization. They failed to manage their organizational networks. They understood what was going on. They built a viable strategy, but they needed the organization and the stakeholders to accept it. In the case of Kodak, people talk about how Kodak didn't see digital photography coming. And people say, if Kodak, if they had jumped on this digital photography thing, they would have been doing great. But Kodak, they had the most successful line of digital cameras there was, the Kodak EasyShare. So they jumped into digital photography. They understood exactly how important it was. The problem wasn't that they didn't address digital photography. The problem was there wasn't any money in digital photography. To this day, the only company that really makes money off of digital photography is Facebook. And they had to somehow replace that cash cow of photo developing with something completely different. And it wasn't going to be digital photography. That's a much, much harder problem. So when you hear these stories about, some company that just completely had their head in the sand, you should immediately be skeptical. Running a large organization is a tough job. It takes a certain amount of intelligence and drive and ambition. If somebody tells you that people running an organization like that were just completely blind to what was going on around them, they're probably not telling you the whole story.
And Greg, there's an interesting one here. Nokia, right? So there's a famous quote supposedly by the CEO who says, "We did nothing wrong." I quoted that at an event I was speaking at, and I got attacked by a senior Nokia executive afterwards, and he said that I was spreading fake news. But I took a point when I read your book, and then I read that blog you wrote about Kodak and Blockbuster. It dawned on me that he was talking about sustaining innovation because he did nothing wrong by focusing on the core business. Where he may have missed an opportunity was by exploration and running a portfolio of innovation, which you talk about in the book, the 70-20-10, for example.
Yeah, what I think people miss, and what I think a lot of the talk at conferences really does people a disservice, is they portray people who get disrupted as some kind of idiot. And the truth is that everybody gets disrupted eventually. And so I think it's every business has to say, anybody running any organization has to say, we've got this great business model that's really doing well. We're beating the competition. Uh, our customers love us. We're making a ton of money. And you got to say, and it's at some point, all of this is going to blow up. And what are we going to do then? Where's our escape hatch? What are we working on now? What are we exploring that can be the next business model when the one we have blows up? One of the things that's so impressive about companies like Google and Facebook is they've been cognizant of that from the beginning. One of the most impressive things that Google does is they iterate a lot of these different strategies. So one of their most brilliant strategies, which almost nobody talks about, I've never actually heard of it outside of talking to Google executives, is that they invite 30 top academic researchers to come and do a sabbatical every year at Google. And the researchers love it, of course, because the data sets they get to work with at Google are absolutely unparalleled. And Google gets some 30 of the top minds in the world to take them in new directions. And that's how they started Google Brain. Some of these people have stuck around for a while. Their research center in Pittsburgh was built around a guy they recruited for a sabbatical from Carnegie Mellon. So they get all these fantastic benefits, and they're very, very cognizant of investing in things like in their X division that have nothing to do with search, but that can be the next huge business model 10, 20 years from now when the search business isn't such a great business anymore.
And Greg, I mentioned briefly Airbnb versus hotel chains. And the reason I did was this. We look at them and we kind of go, I can't believe they missed that. I can't believe Marriott or whoever missed this huge opportunity. But the size of the prize for the Airbnb world versus what they're focused on and what they're working on and what they're sustainably innovating is massive difference.
Yeah, it's maybe 0.5% of the market. And Marriott's doing great, by the way. And if you look at Uber, I mean, they've lost billions. I don't even know how much it is at this point, but probably something like $9-10 billion. I'm not sure that's the actual figure, but it's many billions of dollars that Uber has already lost. And then you look at something like Hertz, sort of chugging along, making $300 million a year, $400 million a year, whatever it is. How long is it going to take for Uber to catch up? They're already $9 billion in the hole. And, 10 years of $400 million in profits, that's another $4 billion. So you got to figure Hertz is, it's not such a bad business.
You say, and I think this is one of the key things of the point of the book, is that what problem are you solving? And every square peg business meets its round whole world. I love that line, man. Your line. And I think this is one of the ones for an Uber versus a hotel. If you're looking to put roofs over people's heads, then that's not what Marriott do. They are about experience, about concierge, about that whole different feeling that you don't get from Airbnb.
And business conferences. I mean, business conferences is a huge one. I mean, that's For business hotels, I mean, a lot of what they do is set up conference rooms and audio systems and catering and all that stuff, right? They That's a very different type of consumer. I mean, certainly that is not a knock on Airbnb, which identified a fabulous business model and have built it out really nicely. Airbnb is now getting into the experience business as well. Actually, a friend of mine who was really struggling, she lives near the Hollywood sign in California, and she's made a pretty good business, almost a six-figure business, just on running tours up to the Hollywood sign through Airbnb. So, I mean, that's a wonderful, wonderful business. It's just a different business than Marriott. That doesn't make Marriott stupid. It doesn't make Airbnb useless. Uh, Different organizations have different strategies and different problems to solve. Again, back to that cargo cult problem. I mean, you need to choose what's right for your strategy, capabilities, and culture. And one of the things that always amazes me, I talk to the people at Apple, I talk to the people at Google, I talk to the people at Amazon, I talk to the people at IBM, and at, you know, world class labs like Argonne and Lawrence Berkeley and MD Anderson, and I talk to entrepreneurs. None of these people sound the least bit like each other. They all have very, very different strategies. They all have very, very different approaches. It's not that one is better than another. It's that these companies are successful because each one has found a formula that works for them. And you need to find your own path to innovation. You can't simply borrow rituals from somebody else and expect them to work in your organizational and strategic context.
I love that, Greg. It teased nicely, and we might finish on this one, but it's a key one, which is people and culture. And you talk about this right at the end of the book, and you talk about some common denominators, I suppose, that were characteristics of many, many innovators that organizations can learn from.
I talk in the book about collaboration being the new competitive advantage. But one thing that struck me about the conversations I'm having lately, when I talk to people about these sort of new cutting edge technologies that are being implemented right now, things like cloud computing, like artificial intelligence, like Internet of Things. The one thing I'm hearing, and that's consistent across all of them, is that they say that the organizations who try and implement them, they always underestimate the people factor. So, for instance, with the cloud, one of the things it does is it does a great job of minimizing the time, effort, and resources you have to expend on infrastructure. But if you want to have a successful cloud effort, you need to figure out how you repurpose those resources to create new value. Because lowering your cost basis for technology, that doesn't mean anything. Everybody's doing that. Moving to the cloud. That's the baseline now. But how are you using the cloud to extend your capabilities and reorganize your human talent so that you can create new value? Very similar with artificial intelligence and automation. When you democratize a capability or a process or a task, you basically commoditize it and value shifts somewhere else. So if you're just using artificial intelligence to reduce your human costs, you're not going to be competitive. You need to figure out how you're going to shift that human talent into new and more productive ways.
I love it, Greg. It's a great way to finish. Mental models, I suppose, need to change business models. But Greg, where can people find out more about you and your work?
Well, I write for Inc.com and HarvardBusinessReview.com or HBR.com. But the best place to find me is on my own site, digitaltonto.com or gregsatell.com. Digital Tonto is my blog, and Greg Satell is my personal website. And of course, the book. mapping innovation.
Yeah, and apart from the book, you run workshops as well for senior executives and businesses.
Yes, I do. And spend quite a bit of time speaking at events.
Excellent. Well, speaker and innovation advisor and best-selling author of the brilliant Mapping Innovation, Greg Satell, thanks for joining us.
Thanks for having me.
Nice one, man.